Good morning. Today we are going to discuss barrel shifter design using pass transistor logic. Before we are getting to today's session, I would like to introduce to myself. I am Dr. J. Prashad, working as an assistant professor in Department of Electronics and Communication Engineering, KPR Institute of Engineering and Technology. Today's presentation is focused on only these three content: a need of register and basic principle of barrel shifter. Once we discuss the basic principle of a barrel shifter, we are going to discuss how to designing of barrel shifter, probably 4x4 barrel shifter using NMOS pass transistor logic. So let me start with my first content, which is called to be a need of register. For explaining this particular content, I am taking in a simple example which is called to be in a processor. The processor, it may be in a digital signal processor or it may be in a microprocessor. The basic unit of processor, it is called to be an arithmetic and logic unit. We all very know that arithmetic logic unit is capable of do both arithmetic operation as well as a logical operation. For performing of either logical operation or arithmetic operation, we need to be force the value to arithmetic logic unit. Probably it should be in binary order or it may be an hexadecimal number. Fine. For storing of that binary information, we need in a temporary devices. That temporary memory device, we called it as a register. Clear? So speaking simply, how we are going to constituting of a register is, which is in a cascade connection of n bit flip-flop, and this is called to be an temporary devices. And this is what my slide say. In my slide I mention as the registers mainly used in arithmetic logic unit for the purpose of storing the values. Fine. Then how that register will be differ from shift register is, like a register, it's in a temporary device, just it's hold the value, it should not be do any processing of stored value. Like in shift register also, it is the same construction of a register, and what shift register will be do is, based on the clock pulse connected to each temporary memory device, the shift register, just it will be shift the data from one flip-flop to other flip-flop. It may be in a left shift or it may be an right shift. So this is what a very basic difference between register and shift register. Like register, it will be hold the value, whereas in a shift register, whatever the register hold the value, based on the connecting clock pulse, it will be do either right shift or it may be an left shift. Next is barrel shifter. So before I am explaining the basic principle of barrel shifter, I would like to tell you how basic shift register differ from barrel shift register. Okay. So like in a basic shift register like SISO, SIPO, PIPO and PISO, and those basic shift registers capable of doing only one bit either right shift or left shift. Whereas in a barrel shift register, it is capable of performing of wrap around or end around shift operation. Then what does the term that wrap around or end around tell us? If shift register is capable of performing the shift operation based on the left rotate or right rotate, then it is called to be an wrap around shift register. So actually that barrel shift register, it is capable of performing of wrap around or end around shifting operation. Okay. So with this note, I am going to explain you how to constructing of barrel shifter. Say for example, let me consider 4x4 barrel shift register. Okay. Four cross 4 barrel shifter. So since the size is 4x4, it has 4 input. I named it as I0, I1, I2 and I3, and 4 output. The output I mapped as output 1, output 0, output 1, output 2 and output 3. So this is a 4x4 barrel shift register. So it is capable of either no shift operation or one shift operation or 2-bit shift operation or 3-bit shift operation. So out of these 4 operations at a given time, the barrel shift register either it will be do no shift operation or 1-bit shift operation or 2-bit shift operation or 3-bit operation. It's like an 4x1 multiplexer design. Okay. So I will explain you how that 4x4 barrel shift register will be responding for these 4 control signal. And remember that barrel shifter at a given time it may be respond for either SH0 command or SH1 command or SH2 command or SH3 command, correct? And I will consider in a truth table. So based on the basic principle of a barrel shift register, it has 4 output: output 0, output 1, output 2 and output 3. Okay. Say for example, barrel shifter has a command signal, I mean control signal, which is called to be an SH0. It means that no shifting of input data. So how it will be respond is output 0 it is mapping with I0 and output 1 mapping with I1 and output 2 it is mapping with I2 and output 3 is mapping with I3. So just it will be assign all the input data as it is without performing of shift operation, correct? When barrel shift register receiving in a command, this is SH1, it means that 1-bit shift, that control signal 0 output it goes to be an 1-bit right shift, and output 1 it is mapping with I0, output 2 it is mapping with I1 and output 3 it is mapping with I2. Since barrel shift register is an end around shift register, the I3 should be mapping with output 0 mapping. And when SH2 control signal activate alone, SH1 further it goes to be an 1-bit right shift, I3, I0, I1 and I2 mapped with output 0. When last control signal SH3 is activated, again it goes to be an 1-bit right shift. So remember that at a given time the barrel shifter it responding for either SH0 operation or SH1 or SH2 or SH3. Clear? So this is what an basic principle and actual working principle of 4x4 barrel shift register. The actual truth table of 4x4 barrel shift register I have constructed based on the basic principle of barrel shift register what we discussed in previous slide. And from the truth table what we observe is at a given time either SH0 is activated or SH1 is activated or SH2 is activated or SH3 is activated. Okay, so this is how the output of a barrel shift register when SH0 is activated alone, it is no shift. When SH1 is activated, this is in a corresponding output. This is 1-bit ROR, and SH2 is activated 2-bit ROR, and SH3 is activated 3-bit ROR. So with respect to the actual truth table only, I am going to explain you how to construct a 4x4 barrel shift register with the help of pass transistor logic.